they actually interact with something called the weak nuclear force, which we also mentioned. Then coming to the quark family right here, this is the quarks family. See, these two rows of particles are the quark family of particles, and we have the up quark, the down quark, the charm quark, the strange quark, the top quark, and the bottom quark. Those are all the types of quarks. These end up being composite particles called hadrons or baryons. The quarks generally are not, generally speaking, hanging out by themselves. They create or they form composite particles along with other quarks. For example, the common ones that we know and love are protons and neutrons. These are the baryons that we are very familiar with. Protons are made of up and down quarks, and neutrons are also made of up and down quarks, but in different sort of different ratios. It's like an up, up and down, and a down, down and up. There's a difference in exactly which exact quarks, but it's a mixture of the up and down quarks is what's in both of them, neutron and proton. I sometimes forget, is the proton the up and down, and the neutron down, down and up? Is that right? Somebody can correct me in the chat, but pretty much I just know that the protons and neutrons are both made up of these two types of quarks. So these are the matter particles that we just spoke about. Okay, so we talked about the leptons and the quarks just now, and see, 3 generations of matter, kind of meaning that the masses of these things actually go up when you go from the 1 to the 2 to the 3 generation. Okay, so like electrons are lighter than muons, muons are lighter than taus. Up and down quarks are lighter than charm and strange are lighter than top and bottom quarks. So these are these particles. But again, pretty much the issue is that you might not meet a lot of the heavier particles that we're mentioning here in the elementary particles of particle physics, because they may decay too fast, and so you won't encounter them too much. Then we come to the force carrier particles. So somebody asked about bosons. These are all the bosons. So if you just kind of ignored all the matter particles and you come to just the force carrier particles, these are the particles in particle physics that carry the different forces, the different fundamental forces. In fact, these are the ones that carry the non-gravitational fundamental forces. There are 4 fundamental forces, including gravitation. Keeping gravitation to the side because we don't really understand it in a particle physics way yet, we see these 4 force carriers. 2 of them carry the same type of force, and that's why we have 4 force carriers here, but 3 fundamental forces that are being covered by these. So photon at the top is what carries, of course, electromagnetism, electromagnetic force. That's a fundamental force carried by photons. Then we have gluons that carry the force strong, nuclear force, another fundamental force of nature. And then we have the Z boson and the W boson right here, Z and W. These Z boson and W boson actually carry the weak nuclear force. That's another type of fundamental force of nature. In fact, neutrinos, the ones, the particles in the lepton family we mentioned earlier, these 3 interact through the weak nuclear force.